Okay, I want to look at another example of moment of inertia. Okay, so this is the example we did. We had two masses far from the axis of rotation, two masses close in. I told you that you could build one of these in front of you with a ruler or a yardstick or a pencil, okay, with an eraser attached, all right? So we saw that the top one was difficult to rotate, bottom one was easier to rotate, okay? Both of these objects had the same mass, but the top one had a lot of its mass far from the axis of rotation, which gave it a large resistance to rotate, so it had a large moment of inertia. The bottom object had the masses close to the axis of rotation. Okay, so it had a smaller moment of inertia. It was easier to rotate. Okay, so we have to look and ask what's in it for us. Okay, so how can someone use this? So actually there's a whole industry that was developed just out of this concept of minimizing a moment of inertia. Okay, so let's say you take a backpack and the manufacturer, they put the pockets for the water out here. All right, so here's some backpacks. This is at Philmont in New Mexico. Okay, so there's a water bottle. Okay, there's another one. All right. Okay, so what people realize is, well, the difficulty with having the water bottles on the outside of the pack is it looks more like this picture. Okay, so you have your heavy items out here. And the problem with that is, if let's say you're standing somewhere, okay, if you're walking around or climbing, that if you have your heavy objects on the outer side, okay, then you have a large moment of inertia, which means not only does it offer a large resistance to rotate, but if you walk and step and your body's rotating and you want to stop, okay, then you also have a large resistance to stop rotating. So your body stops rotating, but all the heavy stuff in the pack wants to keep rotating. It's going to take you with it. So you want to take the heavy stuff, the heavy water bottles, not put them on the outside. You want to put them closer to the axis of rotation. Okay, so you want to move them closer in, but you also need access to water. So how can you have both? You can still have all your heavy water, but you want to put it close to the axis of rotation to minimize the moment of inertia. Okay, so the idea is you want to lower your resistance to stop rotating. Okay, and the solution to that is, okay, whole industry was built on the concept of these water bladders. All right, so what you do is you take all that heavy water that used to be on the outside, and you put it close to the axis of rotation. So it goes in the back of your pack. Okay, so it's still in the pack, but it's close to your back. So it's close to that axis of rotation. So it more looks like that rather than that. Okay, so the smaller mass objects, okay, like for example, your sleeping pad or something that doesn't weigh a lot, that goes on the outside. Okay, that can go far from the axis of rotation. The larger mass items, the heavier items like your water, you want to put that inside close to the axis of rotation to make the moment of inertia smaller. Okay, so what the Camelback does, okay, instead of putting the water bottles far from the outside or far from the axis of rotation on the outside, you put them along your back. So there's you, there's your body. So the Camelback is almost pressed along your back. So now you've minimized your moment of inertia. Okay, so again, you're not changing the mass. Okay, you've taken that water and you've just moved it. So you're not changing the mass, you're just changing how the mass is distributed with respect to the axis of rotation.